Hi, I'm Mario, and today we'll be covering Lab 4 for EE178 at San Jose State University. And in this lab, we implement a finite state machine in Verilog. And after implementing that, we dive deeper into the XDC file, in which we use the pin placement and top level design for our board. And this allows us basically to assign our pins more specifically. And after assigning those pins, we also implement a fully synchronous single clock timing constraint into the file. And basically what this does is it adds a clock as well as input delay and output delay, which the input delay covers paths from flip-flops outside the design, which we cannot see through inputs, to flip-flops in the design. Output delay constraints cover paths from flip-flops in the design through outputs to flip-flops outside the design, which we cannot see. And in the tutorial, we basically implement 5 nanosecond delay for both input and output. And after running the implementation, we receive negative slack, which is not good because these can have negative effects on our hardware, or it can also create bugs within our program. So the goal for this lab is to basically get rid of the negative slack and achieve positive slack, which is what we've done here. As we can see, we have no negative slack, and basically the way we did that is we messed around a bit here with the delays, and the way I got it to work was set a 3 nanosecond input delay and negative 2.5 nanosecond output delay, which gives us a positive slack. And this gives us time closure, which means all of our implementations of the XDC file are working properly, and it should work well. And so that is what we have covered in this lab. And I learned how to work in the constraints file on a deeper level in this lab, which allowed us to work with the clock settings and specify them more to our liking. And that's basically what I learned in this lab. Thank you for watching.